Today, I'm going to be going over how to do problem 6 from contest 4 called glowing digits. Now, you can read the problem statement in depth, which I've linked in the video description, but basically the gist of the problem is you're given the initial state of a digital scoreboard. So for each digit in the scoreboard, you're told which segments are initially on and which ones are initially off, and you want to turn on exactly k segments throughout the entire scoreboard in order to maximize the value displayed on the scoreboard, or say that it's impossible to construct a valid number. So based on our knowledge of place value, we know that when we go about trying to maximize the value of a number, we want to first maximize the value of its first digit. Then, once the first digit is the biggest it can be, we move on to the second digit and maximize that, and so on through the entire number. So let's say we wanted to know if it is possible to make the first digit a 9 and still construct a valid number using the remaining n-1 digits. So let's define a variable called cost to be the number of segments we had to turn on in the first digit to turn it into a 9. So since we know that we have to turn on exactly k segments over all n digits, then it is possible to put a 9 as the first digit if and only if it's possible to turn on exactly k minus cost segments over the remaining n-1 digits. And if it is possible to do this, then we want to know what the maximum obtainable value is by doing so. So we can recognize this as an optimal substructure for this problem, which would motivate us to use DP. So then we just need to figure out what the state, transition, and value of the DP are. Well, the state of the DP is basically just the input for the original problem, n and k. And we don't actually need to store the initial states of each of the digits because we already have that stored. And the digits that any DP state concerns will always be a suffix of the original n digits. So now let's write down what the state and transition, the state and value of our DP are. So based on our example here, we know that the DP needs to have two parameters in its state. The first is the index that it starts at, and then it'll start at the index and then go to the end. And then j will be the total number of bits that you need to turn from off to on. So this is true if it's possible to turn on exactly j segments in the digits at indices from I to the end, right? So based on this definition, we know that that it is possible to construct a valid n-digit array, a valid n-digit number, if DP of 0k is true, right? Because if you think about what DP of 0k means, the 0 means it starts at index 0 and goes to the end. So that would encompass all n digits, and then k is the original number of segments you need to switch from off to on. So this is true, then it's possible to construct a valid n-digit number. Otherwise, it's not. Okay. So then the next thing we need to establish is the transition of our DP. So before we do that, let's actually write a more general form of our cost variable. So cost of I comma d, let's define to be the number of segments we have to turn on to turn the ith digit, so this would be the 0th digit, first digit, so on, into digit d, where d can be anything from 0 to 9. Okay, so this cost function will be pretty useful in determining what the transition of our DP is. So we want DP of ij to become true if it's possible to place some digit at index I and still be able to form a valid digit, a valid number using the remaining digits, so starting at the next index. So that's why the first parameter will be I plus 1. We want to know if we can start at the next index and use exactly a j minus cost of I comma d segments. So j is the number of segments we want to know is possible. It's over the digits starting at index I. So if we use cost of I comma d segments this time, then the remaining ones will have to be j minus cost of I comma d segments. And d can be any digit from 0 to 9. Right? For any digit d from 0 to 9. Okay. So this would just this basically goes through trying to put every possible digit on the current index I. Okay. So this establishes the transition. So then at the end we just need to check if dp of 0 comma k is true. And if it's not, then we just print -1 and move on. But if it is true, then we have to actually construct the maximum value of the number. So to do that, we would just use the strategy we discussed earlier, which was just going through the digits from left to right. And on the current digit, we want to maximize it. So we would iterate through the digits in decreasing order, so from 9 to 0, and see if it's possible to put that digit at the current index I. So let's say that we were trying, and then to know if it's possible, we would just use the DP matrix that we've just finished computing. So as an example, I'm gonna go through how you would know if it's possible to put a 9 on the 0th index. So if dp of 1 comma k minus cost of 0 comma 9 is true, then it's possible, because this cost of 0 comma 9 basically describes the number of segments we need to change the 0th digit into a 9. And then so then you would have to use k minus cost switches in the remaining of the remaining digits of the array starting at index 1. So now I'm going to actually code the solution so you can see the implementation of it. So the first thing I'm going to actually do is copy in these binary strings that represent the 10 digits, because they'll be useful in computing the cost function. So we'll make a string array called digits to copy these into. And then next we just need to read in the input, which starts with n and k. And then we're going to store the n digits as strings, because that will make it easy to compare to these digits using char at. And then we're just going to read in the n digits as strings. Then we have to write the cost matrix. So it's going to be an int matrix with the dimensions. If we go here, the first dimension can be any index, so it'll be size n. And then d can be any digit, so size 10. All right, and then quickly here, I'll just write the definition of cost. So this is the number of segments we need to turn on in the ith digit to make it into digit d. And it's gonna be infinity if impossible. Okay. So now we can just loop over the entire cost matrix, and then we need to go through all the bits. So I'll call the bit b. So basically every time a bit needs to go from 0 to 1, we need to increase the cost by 1, because that means it costs 1 segment change. So if we start at 0 and we're going to 1, then the cost will go up by 1. But on the other hand, we need to check if we start at a 1 and go to a 0, which is impossible. So to check this, start at a 1 and then we want to end up as 0, then it's impossible. So we're going to set this to an infinite value, and then break once we know it's infinity. So I'm going to make a static variable here called infinity. That will just be a very large value. Okay, so now we finished computing our cost matrix. Now we have to do the actual DP, which will be of type Boolean. And if we look at the size of it, DP, so I can be an index, so that's going to be n. And then j is the number of switches, so that would be k. But we actually want k to be a valid index for this, so we're going to make this k plus 1. And then we can actually also make this first parameter have size n plus 1, because as a good base case, we can use dp of n comma 0 to be true. because this seems like it's invalid because if you start at index n, that's actually an out of bounds index, but that's actually what we want because this would mean that it covers 0 indices. So obviously it's possible to turn on 0 segments in 0 indices. So this can act as a good base case. And then here again, I'm gonna write just define what dp of ij means. So this is true if it's possible to turn on exactly j segments in the digits at indices from I to the n. Okay. Then since the base case had its first parameter as n, we need to actually loop over the first parameter in backwards order. So starting at n minus 1 and then going downwards. And then it doesn't matter which direction we loop over the second parameter because if you look at the transition, computing the value of a state only depends on the states where the first parameter is one higher. So since we already have all those computed, since we're going through the first parameter in the correct order, it doesn't matter which order we go through these. So I'm just going to go in ascending order. And then it needs to go from 0 to k because those are the possible numbers of total switches that we have. So to know, to compute the transition, we need to loop over all d digits. So we're gonna look through all the digits, and then I'm gonna use a structure called or equals. I'm gonna first type it and then explain what this means afterwards. So basically, dp I plus 1 j minus cost is basically we use cost segments to change the digit at index I into digit d. So that means that this is the remaining number of segments you can use for the digits starting at index I plus 1 and going to the end. Now what or equals does, it takes the or of this expression and this expression and assigns it into this variable. So what this means is if this is true, it will stay true no matter what. But if it's false and this is true, then it will become true. So so this will be our transition. And then we also need to check one thing. We need to check if this is a valid index. Because if it's an invalid index, it would be out of bounds, and then and that for sure wouldn't work. So it will also give us an error. So you don't want that. So at this point we've computed our entire dp matrix. So then all that's left is to check dp0k. So if dp of 0k is false, that's actually an easy case. You can just print -1 and then you're done. But otherwise you have to actually compute what the maximum value is. So to do this, we're gonna go through the indices from left to right. Right, and then at each index we want to find the maximum digit that we can put at the current index. So we're going to loop through the digits in descending order. Okay, and then to see if it is possible to put digit d at index I, we're going to look at basically if dp of I plus 1 and then k minus cost of I comma d is true. Okay, so basically what this means is you use cost id to put digit d at index I. So we need to know if using this remaining number of segments is possible for the segments starting from I plus 1 and going to the end. So if this is true, then that means it's possible to put index d at index I, so we print that. And then we also need to decrement k by this cost value, because that means that we use this cost value, so that means we can't use it again, right? So and to decrease k by the number of segments that we just used, and then break, because we don't want to print more digits for the current index if we already found one that works. So we break there and then print an extra line at the bottom. So that should be a complete solution. I already have a test file with one of the sample cases, so let's run it to see if this works. Oh, here I actually didn't. Okay, I didn't check if this was a valid index. So yeah, it's just like up here, but I just forgot to check it this time. So that has to be a valid index in order for it to work. So 97, I believe was the correct value. 97, yeah. So I'm gonna change this to system.in and submit it. And then it's accepted. So yeah, thanks for watching.